Good morning, students. Today we are going to discuss the image formation by concave mirror. In the last class, I have discussed the rules, that there are three rules. You just recall it. First rule was when a ray of light is parallel to principal axis, it will always pass through focus after reflection. Another rule was just opposite of it, that when a ray of light passes through focus, it becomes parallel to principal axis. And third rule was that when a ray of light passes through center of curvature of a spherical mirror, it returns back along the same path after reflection. So I think you already gone through the rules. So many students have shown their assignment also. Not all, but so you must practice it. It is very important topic, and I think you will get questions in board examination from this topic. The ray diagram portion is very important. So now today, image formation by concave mirror. So as you can see, there are 6 cases. 6 cases, it means we will place object in these places from concave mirror. First, when object is infinity. When object is at infinity means object is very far away from the mirror. You can consider sun as an object that is infinite distance from the mirror. Second case, when object is beyond center of curvature. C stands for center of curvature. Then we further shift the object towards the mirror. So the third position is when object is at C. Fourth is we further shift the object towards the mirror. So object is between C and F. And fifth case, when object is at focus or at principal focus. And sixth one is when object is between pole and principal focus. So out of these 6 cases, I will draw a diagram for 3 important cases. First one, third one, and sixth one. And rest of the cases, it means 2, 4 and 5 is your homework. You will also try it. So this is the common diagram that you have to draw a concave mirror first. Suppose this is a concave mirror, the inner side is the reflecting surface. Mark a point at the center of the reflecting surface, and as you know, name of this point is pole. Okay, then through pole you have to draw a horizontal straight line, and this line is known as principal axis. Now mark a point C and then a point F exactly between P and C. So this much drawing is common for all the cases. I have written all the 6 cases here. So this much you have to draw in all the cases. This much drawing is common. Now first case, when object is at infinity. So we are not going to draw object on the principal axis because object is very far away from the mirror. So when object is very far away from the mirror, we suppose that parallel rays of light are coming from the source. So suppose sun is the source which is at infinite distance from the mirror. And you know how many rays are required to make an image? At least 2 rays. Actually, so many millions of light rays are coming. But for simplicity, we are taking 2 light rays because at least 2 light rays are required to make an image. So suppose 2 parallel light rays are coming from the sun. Suppose these are the 2 parallel light rays. So according to first rule, recall the rule that a ray of light which is parallel to principal axis pass through principal focus after reflection. So these two rays will pass through focus like this. So where the rays are meeting? The rays are meeting at F. So the reflected rays are meeting at F. So image will be formed at F. So first write these things: position of image. So we will write position of image at F. We are getting an image at F. Then write its size. So two rays are meeting at point F. So it is point size image. And then you have to write the nature. Nature means whether image is real or virtual, it is erect or inverted. So what do you think? The light rays are actually meeting at F. Really they are meeting at F after reflection. So image is real. And real images are always inverted. So nature is real and inverted. Is it clear? So this is the first diagram which we have drawn when object is at infinity. Now we will discuss another case when object is at C. So again you have to draw a concave mirror, mark a point P at the center of reflecting surface. Like this. Now this time we will draw object at C. So suppose AB is the object. I have drawn an object. Suppose name of this object is AB. So AB is the object and I have placed the object at center of curvature. Now again we will take a ray of light from the object parallel to principal axis. So take a ray of light. Suppose this is a ray of light which is parallel to principal axis. So this ray will pass through focus after reflection. So straight, but you have to draw a straight line through scale. Okay. Now take another ray through principal focus of the concave mirror. Suppose this is the ray which passes through principal focus of the mirror. Now arrows are very important. You must put arrow in your ray diagram, because if you will not put arrow in your ray diagram, half marks will be deducted in board exam also. Arrow shows the direction of light, in which direction ray of light is moving. So as we have learnt earlier, when a ray of light passes through focus, it becomes parallel to principal axis. So this ray will meet here after reflection and you will get an image at C. Name this image. Suppose A dash B dash is the image. So this time we are getting image at C. So very important case. When object is at C, image is at the same point, it means at C. Now the rays are actually meeting, so image is real and you see it is inverted one, and size is equal to the size of object. Equal to the size of object. Here AB represents object and A dash B dash represent image. So we have discussed the third case. I think it is clear to you. Now the last case, which is very, very important. Okay, again you have to draw a concave mirror like this. Then mark a point P at the center of reflecting surface. Suppose this is center of curvature and this point is principal focus. So this time object is between pole and focus. So place object between these 2 points. Let AB is the object. We have placed the object between pole and focus. Again we will take a ray parallel to principal axis. So from point A you take a ray of light which is parallel to principal axis, and as we have discussed earlier, according to rule, this ray will pass through focus after reflection. So the ray will pass through focus like this. Must put arrow. Then take another ray of light through center of curvature of the mirror. So according to rule, if a ray of light passes through center of curvature, it will return back along the same path. So this ray will pass through center of curvature, and after striking the mirror, it will return back along the same path. That's why I have put an arrow in backward direction. Now the two reflected rays are not meeting at a point here, isn't it? So in this case, we will extend the rays virtually behind the mirror. So if you will extend these two reflected rays, virtually they will meet behind the mirror, and you will find that a magnified virtual erect image will be formed behind the mirror. So this time position of image is behind the mirror, size is magnified, and nature, as we can write, nature is virtual and erect. Virtual because the two reflected light rays are not meeting at a point. Actually, really, they are meeting behind the mirror virtually. काल्पनिक रूप से वो मिल रहा है मिरर के पीछे, इसलिए यहाँ पे नेचर होगा virtual. It means we are getting a virtual image, and virtual images are always erect. So A dash B dash is the image. Now next topic is uses of concave mirror, and there is an important question that why concave mirrors are used as a saving mirror. First, why we use concave mirror for saving purpose. So this is the reason that when your face is very close to the mirror, suppose we have placed the object between pole and principal focus of a mirror, then we will get a virtual magnified view of our face, and that will be an advantage during saving. That's why concave mirrors are also used as a saving mirror. So the three cases I have discussed, first, third and sixth one. These cases are important, and rest of the cases 2, 4 and 5 is your homework. We will discuss next topic in the next class, that usage of concave mirror.